in this circuit diagram we have a voltage source of magnitude Vs, and in the load a constant current source is connected. It draws a constant current IL. Okay. Then we have to find out the value of IL such that the power delivered in this current source will be maximum. Let us, this is an element, so we have to maximize power delivered in this element. Okay, so let us first find out the expression of power in this current source, the expression of power that this current source absorbs, and then we will differentiate it. We have to find out value of IL. So first we will find out the expression of power in current source IL as a function of current IL, and then we will differentiate it in terms of IL because the variable is here IL. We will differentiate power in IL with respect to IL only, and we will equate it to 0 such that power will be maximum. So power across IL will be, the power absorbed in IL will be voltage across this current source into current is nothing but IL only. So basically we have to find out voltage across this element. Let's say this is plus, this is minus. If this is a current IL, so the same current will flow through this resistance. Let's say this is voltage V. Now if you will apply KVL, here you have gain of voltage Vs minus IL into R minus V equal to 0. So V will be Vs minus IL into R. This is voltage across this current source. So power PIL will be Vs minus IL into R into current IL. Now let us differentiate it. So dPIL by DIL will be Vs minus 2IL into R, and this has to be 0. So IL will be Vs divided by 2R. So for this value of current or a current source having this value of current, will draw the maximum power from this voltage source. In this circuit, initially the switch was connected to position 1 for a long time. It means that when this switch was connected to position 1, the circuit was in a steady state. Now at t equal to 0, the switch was abruptly connected to position 2. Then there will be a transient. According to which capacitor voltage will change. So we have to find out equation of capacitor voltage in terms of t. We have to find out VCT for t greater than 0 after the transient occurred in this circuit. So to solve this question, the basis of solving this question is current or voltage across resistance can change instantaneously, but voltage across capacitor cannot change instantaneously. And to find out equation of capacitor voltage, we will use this formula, V infinity minus V naught into e to power minus t divided by tau, where V infinity is, this is a steady state capacitor voltage, steady state after transient. After transient there will be a circuit because there is a switch of connection. So after transient again there will be a steady state. So V infinity is a steady state voltage of new circuit after transient, steady state voltage, and V naught is capacitor voltage just after transient, and capacitor voltage cannot change instantaneously even after transient. So capacitor voltage just after transient, that is Vc 0 plus, because at t equal to 0 transient has been occurred, this voltage will be equal to just before the transient, because capacitor voltage cannot change instantaneously. So first we will find out the capacitor voltage before transient. Before transient, the switch was in position 1 and the circuit was in a steady state. So what will be the capacitor voltage? In a steady state, there will be no current through the capacitor, so whatever current will flow, it will take this path. Okay, so this 10 volt will be equally divided in these 2 ohm resistances. So here voltage will be 5 volt, so the voltage across capacitor will be 5 volt before transient, and just after transient also this voltage will be 5 volt. So V0 is 5 volt. V infinity is the steady state capacitor voltage after transient. So after transient, switch is connected to this position. Okay, so now in this state we have to find out the steady state capacitor voltage, and that will be V infinity. Again, in a steady state there will be no current through this capacitor, so this 5 ampere will flow through 2 ohm resistance, and whole 5 ampere current will again come to this 2 ohm resistance. So voltage across this 2 ohm resistance will be 10 volt. This is disconnected, there is no current in the capacitor, so no current will flow through this 4 ohm resistance. If there is no current in this resistance, there will be 0 voltage drop. So here voltage difference is 10 volt, there is no drop, so here also voltage difference will be 10 volt. So V infinity is 10 volt. Now even before finding out the complete expression, now you can start checking the options. We already have right after transient at t equal to 0 plus, capacitor voltage has to be 5 volt. So when you will put t equal to 0 plus, this expression will give you 4 into 1 minus, if you will put t tends to 0 here, you will get 0 volt. This will be 1 minus 1, this is 0. But right after transient, capacitor voltage is 5 volt, so this option is wrong. In the question, this is not 2 ohm, this is 3 ohm. Okay, by mistake I took this resistance as 2 ohm, actually this is 3 ohm. Okay, now if this is 3 ohm, so and this is 10 volt, by voltage division, here voltage difference will be 4 volt, and here voltage difference will be 6 volt. Okay, so instead of 5 volt we will have 4 volt here, this will be 4 volt. Okay, so the just before the transient and just after the transient, the capacitor voltage will be 4 volt. So first option, this gives you 0 volt, so this option will be wrong. If you will put t equal to 0 or 0 plus, this will give you 4 volt, so this option may be correct. If you will put t equal to 0, this will give you 0 volt, so this option is wrong, and this option will give you correct result 4 volt. So now we have to check for out of B and D options. Now in option B and D, now if you will check for the steady state capacitor voltage, when the switch is connected to position 2, you will put t equal to infinity. When you will put t equal to infinity, this will give you e to power minus infinity, and e to power minus infinity is 0, so this will give you 10 volt, which is correct, and D option will also give you 10 volt, So again you cannot discriminate or you cannot eliminate either of the options B and D on the basis of steady state voltage. But in these two options the time constants are different. So you check time constant of this circuit. To find out the time constant of this circuit, time constant is nothing but Thevenin equivalent resistance across terminal of C into capacitance. So across this terminal you have to find out Thevenin equivalent resistance. You have 4 ohm here, this is 2 ohm, this is 4 ohm, and this is 2 ohm. You have to find out Thevenin equivalent resistance across the terminal where capacitor was connected. And while finding out Thevenin equivalent resistance, all the sources are deactivated. If there is a current source, it has to be open circuited. If there was a voltage source, that would be short circuited. So current source is left open circuited. Now if you will find out the equivalent resistance, the resistance will be 4 plus 2, 6 ohm. So RTH is 6 ohm and capacitance is 0.1 farad. So tau will be 0.6 second. Okay. So this is e to power minus t divided by tau. In option B, the time constant is 0.5 second, and in option D, the time constant is 0.6 second. So D option will be correct. Okay. Now let us find out the whole expression. Just for obtaining the answer, you need not always find out the complete expression. In between, while finding out the complete expression, in between you can get your answer. Okay, you have V infinity initial voltage. Now apply this formula. V infinity is 10 volt minus 10 minus initial voltage is 4 volt into e to power minus t divided by tau equal to 0.6. This will give you 10 minus 6 into e to power minus t divided by 0.6. This is the case of parallel resonant circuit. The circuit is in resonance. The source current is a sinusoidal current source. So in resonance, we are required to find out the ratio of magnitude of inductor current to the magnitude of resistance current. Now if this circuit is in resonance, okay, this resistance is 10 ohm, inductance is 10 milli means 10 millihenry, and capacitance is 10 microfarad. Okay, now if this circuit is in resonance, this part will provide an infinite impedance. In case of resonance, the LC part, the parallel circuit of LC combination, this will provide an infinite impedance. So equivalently there will be no current in this part. It is not, I am saying equivalently there will be no current in this part of the circuit, but it doesn't mean that inductor current and capacitor current will be zero. There will be inductor current and capacitor current, but inductor current and capacitor current will cancel each other exactly. So equivalently no current will come from the source. So whatever current is supplied by source, let's say this current is I, source current, this current will flow through the resistance 10 ohm. So the magnitude of resistance current is Is. Okay, if magnitude is Is, the voltage will be Is into R, and since these three elements are connected in parallel, so this will be resistance voltage equal to capacitance voltage equal to inductance voltage. Now voltage across inductance is known as, this is Is into R, and impedance offered by this inductance will be impedance offered by this inductance will be XL is omega L. Okay, so inductor current or the magnitude of inductor current will be VL divided by XL, ISR divided by omega L. R is known, L is known. Okay, the magnitude of IL will be magnitude of IS R. This is magnitude of voltage divided by magnitude of impedance. So magnitude of IL divided by magnitude of IS will be R divided by omega L. And since this circuit is in resonance, so the angular frequency will be at resonance. And at resonance we know that the frequency is, for parallel RLC circuit, the resonance frequency is 1 by root LC. So at the place of omega we will put 1 by root LC into L. This will give you R divided by root under L by C. Okay, R is 10 ohm, L is 10 millihenry, which means 10 into 10 to power minus 3 divided by capacitance is 10 into 10 to power minus, this will give you 10 by 10, this is 1. Magnitude of inductor current divided by magnitude of resistance current, which is IS, this will be equal to 1. The capacitance is 10 microfarad, so 10 microfarad means 10 into 10 to power minus 6. Okay, so this will not be 1, this will be 10 divided by root under 1000 or 1 by root 10. This is 0.316. So this will be the correct answer. In the previous question, you don't even need to find out the exact value of current in the resistance, since all the elements are connected in parallel. Okay, so current here will be V divided by R, and here current will be V divided by omega L. Okay, so the magnitude of IL divided by magnitude of IR will be V divided by omega L divided by V divided by R. This will be R by omega L. Then use the value of omega for the condition of resonance. You don't need to find out exact value of current that is entering into the resistance, because that value of current will be cancelled out. For this T network, the Z parameter is given. This is impedance ZA, ZB, ZC. So for this T network, Z parameter is given, and it is assumed that ZB is, this is a combination of resistance and reactance. So with the help of Z parameter, we are required to find out the resistance RP. In theory lecture or in two-port network, after studying Z parameter, this is the first example that we normally study. So for this T network, the formula for Z parameter is Z11 is equal to ZA plus ZC, Z12 equal to Z21 equal to ZC, and Z22 is equal to ZB plus ZC. Okay, so Z12 equal to Z21 equal to given as J omega, so ZC equal to J omega, and Z22 is given as 3 plus 2J omega. So 3 plus 2J omega, that is Z22, this is equal to ZB plus ZC is nothing but J omega. So ZB equal to 3 plus J omega, and ZB is assumed that this is RB plus j omega. So by comparing, this is j omega, Rb has to be equal to 3 ohm. In this network, each resistance has a value of 1 ohm, and we are required to find out the equivalent resistance across the terminal A and B. Okay, so if we observe it carefully, this is a delta connection. The outer resistance, the resistance in the outermost triangle, this is a delta connection, and the inner resistances in innermost triangle, this is also a delta connection. So let us first convert these three resistances in star. These are the three terminals. So while converting from delta to star connection, the terminals are not changed. Instead, all these three resistances will be connected in a star across these three terminals. So in a star, we will have a extra terminal which is neutral, and all the resistances, the star connected resistances, will be connected across terminal and neutral. Okay. So let us convert this delta connected resistances in star connection. Now when you will connect it in a star, this resistance and the outer resistance will be in series. Okay. Now in case of delta connection, if all the resistances are equal, all the resistances are 1 ohm, when you will convert in a star connection, all the resistances will be divided by 3. So all the resistances will be 1 by 3 in case of star. So let us erase it. The delta is converted into star, and now each resistances will be 1 by 3, 1 by 3 and 1 by 3. Now this is 1 ohm and 1 by 3 ohm, these are in series, so this will be 4 by 3 ohm. This is also 4 by 3, this is also 4 by 3. So we have a star connection of resistances whose values are 4 by 3, 4 by 3 and 4 by 3. All these values are 4 by 3. Now let us again convert the inner star connection to delta connection. If you will convert these resistances to delta connection, the connection will be across these three terminals are not changed. Okay, and all these resistances are equal. So after conversion, the equivalent resistances will be connected across these three terminals, and the resistances in outermost triangle, these are also connected across these three terminals only. So after conversion of this star connection, the equivalent resistances will be in parallel to the resistances connected to outermost triangle. So this is the delta conversion of inner star connection. Okay, now remove it. All the resistances were 4 by 3 ohm. This is the equivalent delta connection. So in delta connection, resistance gets multiplied by 3. So these resistances will be 4 ohm, 4 ohm and 4 ohm. And this is 1, 1 and 1. Now these are in parallel. The parallel of 1 and 4 will be 0.8. This is terminal A, this is B. So across AB we will have 0.8. Let's say this is C terminal. So between A and C we will have 0.8, and between B and C again 0.8. These two 0.8 are in series. This is 1.6 and 0.8 is in parallel with 1.6. Okay, so the equivalent resistance across AB will be 1.6 into 0.8 divided by 1.6 plus 0.8. This will give you 8 by 15. So this will be the equivalent resistance between terminal A and B. In this circuit we have a voltage dependent current source. If voltage across 5 ohm resistance is Vx, the current in the dependent source will be 0.04 into Vx. So this is a dependent source, 60 volt. This is a independent voltage source. Then in this circuit we have to find out the current through resistance R2, current in this 3 ohm resistance. This is 5 ohm resistance. Okay. Now let's say voltage is Vx here. So current in 5 ohm resistance will be Vx divided by 5, and same current will flow through 3 ohm resistance. Here current is 0.4 Vx, this current is 0.4 Vx, and this current is 0.2 Vx, 0.2 Vx, and current in upward direction is 0.04 Vx. So here current will be, this current plus this current is 0.2 Vx, this current will be 0.2 Vx minus 0.04 Vx, this will be 0.16 Vx, 0.16 plus 0.04, this will make 0.2. Okay, so we have current in all the resistances in terms of Vx. Now if you will apply KVL in this loop, we have only one variable, we have only one unknown, that is Vx. So here we will have gain of 60 volt. I am directly writing it, is equal to 5 into 0.16 Vx plus 0.2 Vx into 3, and here the voltage drop is Vx plus Vx. This is total voltage drop, this is total voltage gain. 60 will be equal to, this will be 0.8 Vx, this will be 0.6 Vx plus Vx. Okay, so from here Vx will be 25 volt. If Vx is 25 volt, we are required to find out current through 3 ohm resistance. So current through 3 ohm resistance is 0.2 Vx. So the answer current will be 0.2 into Vx is 25 volt, this will be 5 ampere. In this circuit, initially this switch was closed and this circuit was in a steady state. So when this switch was closed, in a steady state what will happen? The current will flow through this path because the reverse current of the diode is 0. So current cannot take, even a small amount of current cannot take this path, cannot flow in this direction. So in a steady state, when the switch was closed, current will flow in this path. In a steady state, when the switch was closed, the circuit will look like this: 10 volt, 1 ohm and inductor. And in a steady state, the voltage drop across inductor is 0. Inductor behaves as short circuited, so the current will be 10 divided by 1, 10 ampere. Now at t equal to 0, this switch was open circuited, but inductor has a current of 10 ampere, and inductor current cannot be made suddenly 0. So this has to have a path. This 10 ampere has a path to flow. So this current will take, because this switch has been open circuited, so only one path is left. So this current will now flow through capacitor, and in this case diode will be conducting. For this direction of current, diode will be conducting, and when it is conducting, this will behave as short circuited because it has 0 voltage drop. So after opening this switch, we will have a circuit. I am drawing that circuit. The initial inductor current is 10 ampere. Diode is short circuited, and this is capacitor. It is not physically short circuited. Diode will be physically connected, but for this direction of current, it will behave as short circuited, and this is reference of capacitor voltage. So now we have the case of LC oscillation with initial inductor current of 10 ampere and initial capacitor voltage was 0. Initial capacitor voltage is 0, initial inductor current is 10 ampere. Okay, so we have already studied in theory lecture of LC oscillation. If inductor carries an initial current, the expression for inductor current will be I naught cos omega naught t, and expression of capacitor voltage will be I naught into Z sin omega naught t. If there is no diode in LC oscillation that we have studied in theory lecture, if there is no diode, this current will keep oscillating. It will flow in anti-clockwise direction, and as capacitor will be charged, magnitude of current will decrease in this direction. When capacitor is fully charged, the inductor current will be 0, and then again current will continue in clockwise direction. This is LC oscillation. So in LC oscillation, this is the formula for current, and for the proof you can refer the theory lecture of LC oscillation. But here we have a diode with this polarity. If you will draw the graph of inductor current, the initial inductor current is 10 ampere. This will be the graph of inductor current. Initially current is flowing in anti-clockwise direction, and initially current is 10 ampere. So at t equal to 0 plus, I have taken positive current, so the positive current is for anti-clockwise direction. Okay, and since we have a diode here, so current will be allowed in anti-clockwise direction only. In complete LC oscillation, after this point current will be in clockwise direction, but due to diode, after this point the current have a tendency to be negative, and negative current is clockwise current. So after this point diode will be open circuited, and there will be no current in the circuit after that. If there is no current in the circuit, so the capacitor voltage will become constant. So this circuit will conduct only up to this part of the LC oscillation. Okay, at this point inductor current is 0, and expression of capacitor voltage is I naught Z naught sin omega naught t. When the inductor current is 0, okay, initially inductor current is 10 ampere, and this is a graph of cos, so this will be pi by 2. Okay, when for the first time this expression is 0, obviously omega naught t, that angle will be pi by 2. So here the angle is pi by 2. So for pi by 2, sin omega naught t will give you 1. So capacitor voltage will be I naught into Z naught. Vc is I naught is 10 ampere, and Z naught is the natural impedance of this circuit. In the theory lecture we have studied that the natural impedance is root under L by C. Root under L is 1 millihenry, 10 to power minus 3, divided by capacitance is 10 microfarad, 10 into 10 to power minus 6. So this will give you 100 volt. There is another way to find out capacitor voltage. Capacitor voltage will be, or if you start from beginning, initially inductor has a current of 10 ampere, and this diode allows the inductor current in anti-clockwise direction only. Okay, so the current will keep flowing in anti-clockwise direction till the inductor current becomes 0. Okay, inductor current will keep flowing in anti-clockwise direction till the inductor current becomes 0, because inductor current cannot suddenly change its direction. So it has to first decrease to 0, then again current may flow in clockwise direction, and that even that will not be allowed due to diode. So inductor current will decrease from 10 ampere to 0 ampere, and it will keep flowing. When inductor current is 0, current will have a tendency to flow in clockwise direction, and at that time diode will be open circuited. Okay, and there will be no further transient. So initially when inductor had a current of 10 ampere, the total energy in this system was half Li square, half L into 10 square. Okay, and when inductor current goes to 0, the total inductor energy becomes 0. So where has the total energy gone? The total energy is stored in the capacitor. So energy stored in the capacitor will be half CVS square. Okay. Half and half, because there is no third element, there is no resistance in the circuit, so the total energy will be conserved. Whatever stored energy is in inductor, this stored energy will be transferred to the capacitor. So V will be, or V naught will be 10 divided by, or 10 into root under C by L, or no, this will be 10 into root under L by C, the same expression what we got here.